All right, class. The printer kind of ran out of black ink, but if you pulled up the lesson digitally on Google Classroom, you can definitely maybe read it or have it up. I'll read it out loud for you anyways. So I want you to write the linear function below in point slope form, m times x minus x1 equals y minus y1, and then turn it into slope-intercept form, which we did in class and for homework. So I'll give you a minute. If you missed the lesson, or if you want to review how to do this sort of stuff, great lesson to do it. This is lesson 34. All right, spoiler, or unless you want to follow along, it says to write the linear function in point slope form. So to do that, actually, we need a slope and we need points, a point. Oh, I found one, two, three different points we could use. We only really need one. The only thing we're missing though is slope, so I guess we have to find the slope because we can't write the equation without it. Well, good thing is we have points. We have two of them. So I'm going to use rise over run. Make sure they're counting by ones. Yes. All right, so our slope is rise 2, run 1, but our type of slope is negative, so I'm going to say this is a slope of negative 2. All right, what's this? We need a point, but I see 1, 2, 3. Usually someone says, well, they can use kind of use any of the 2 points. It's kind of whichever one you might want to use. I'm going to go with negative 5, 0. Sure, why not? But you could find the slope, point slope in any other form. So we got negative 2 times x minus negative 5 equals y minus 0. And so there you go. But you might have written it with the point negative 6 too. So could have been this one. This is also the same. Or you could have written it as this one. So depending on which point you chose, you get a different point slope formula, a point slope form. Okay? Then I told you to turn them into slope-intercept form, and here's the really interesting part. Normally I have students who chose different points come up and kind of show their work on how they got the point slope form. But I'll just do that here. So remembering to distribute, right? And then you get negative 2x plus negative 10 on this one. Here I'll distribute. And then if I solve it for y, interesting enough, so what do we notice? Even though we use maybe 3 different points to write our equation in point slope, when we write it in slope-intercept, we get the same answer. So it proves that all of these are equal to each other. Sweet. Okay. One of our last topics in chapter 4 is talking about parallel lines. Okay, so give yourself this heading in your notebook. This is 4.8. We're going to talk about parallel lines. So 4.8 parallel lines. What would parallel lines look like if you're going to draw them? Parallel lines. Yeah, like that's kind of like that, right? Like two, and what's the definition of parallel lines? Please remember, 2 lines that never cross. Right. So parallel lines are 2 lines that never cross. And because they're lines, hey, we're studying them. Linear functions, linear functions. So something else is true about lines that are parallel to each other, besides that parallel lines never cross. Right? You studied me when younger, parallel lines never cross. Okay. So here we go, and I want you to kind of discover it on your own. So write an equation for each line in slope-intercept form. Okay. And then what statement can you make about parallel lines? Right. So you would have this handout in class, and I would have you turn and talk to a neighbor, and you guys find the slope. I would make sure to notice that the y values are counting by 2, while the x values are counting by 1, so just to be careful with that. All right, so once you find the slope of the blue line, and then find the slope of the red line, write the equation, and then see what you notice about parallel lines other than they don't cross. I'm going to get started finding it, but you can go ahead and do it yourself as well. Okay, so you write the equation for lines, which we're good at. It has the y-intercept, so we can just write the equation. So now that we can see the equations for parallel lines, what else can we say about them besides that they don't cross? Anything you notice? Yeah, looking at their equations, I can see that the number next to x is the same number, and that's actually true. So we can add that to our notes, that parallel lines have the same slope, right? And slope is steepness, which makes sense, right? Steepness. So parallel lines have the same slope as steepness, but they do have something different. What's different about these two? Different y-intercepts. That's all right. Okay, so it's a little bit hard to see, but here's an equation of a line. Y equals negative 4x plus 10. Right. What's the slope of this line? Negative 4, right? Okay, cool. All right. Can we write two equations in slope-intercept form that are parallel to this line? So if we have this line, y equals negative 4x plus 10, take a moment. What would be two other equations that are also parallel, to this line? Remember what we just talked about up here, right? Right, and that's where I take some answers. Negative 4x plus 2, y equals negative 4x minus 7, y equals negative 5x plus 10. Nope, can't do that. Let's do 100. Y equals negative 4x plus 30. How are we doing this so easily? How are we listing all these ones? Well, parallel lines have to have the same slope, so the same coefficient of x, which they all do, and they have different y-intercepts. Okay, so why does it make sense that parallel lines have the same slope? Right? Why would they have the same steepness? It's a really interesting question. So why do parallel lines have the same steepness? And here's where I would turn and talk to your neighbor. Why does parallel lines have the same slope? And then someone would raise their hand and say something like, well, they have to be just as steep as the other one because otherwise they would cross, right? And I'm like, wow, that's great. They have to be equal space between each other. So if they were different steepnesses, right? If they were different steepnesses, they would have to intersect. But the only way for two lines to not cross is if they're going in the same direction, with the same steepness, the same mountain. Cool. I guess I kind of show that. Yeah, let's do that. The same question twice. Okay. So again, we don't do this, but equations that are parallel to this, they just have to have the same slope, but different y-intercepts. Okay. Now those would be super easy, right? But that's not where we're going. We're just getting us to think about it. This next problem is what we're going to be actually challenged to do. So, you're going to turn and talk with your neighbor, but I'll get you started first. Here's the equation for the linear function in slope-intercept form. So, we have y equals 1/7 x plus 1. That is the equation for this line. That's its slope. That's its y-intercept. Good so far? All right. Here's where I'm going to get a little bit more specific. We want to try to write the equation for a line in our new form, point slope, for the line that passes through the point 3,5. So we're trying to write an equation for a line in our new form for a line that passes the point 3,5. So I want you to mark that off. 3, 5. So we get this new line. Point goes through the point 3,5. It's parallel to this equation. So just to visualize, sketch in. So what would the equation for this line be in point slope? But it also has to be parallel to that. All right, what we find is that, well, this new line, right, has the same slope. So this new line, we know that its slope has to have the same as this one. So 1/7. What else do we know about this new line? Well, we know it goes to the point 3,5. Oh, we can write the equation in point slope, right? We just did last lesson, which is m times x minus x1 equals y minus y1. So 1/7 x minus 3 equals y minus 5. So we now can write the equation for any line parallel to another line. Not just any old ones, but we're going to be real specific. I'm going to give you a point, you have to write the equation for that specific line. Not any line, like we did up there, but this one right here that goes through 3,5. Alright. Some other small things. What is the slope of this line here? 3x plus y equals 12. Because we want to help with parallel lines, we have to have the same slope. So if I want lines parallel to this one, what's our slope? And people always yell out 3. And I say, nope, it's not 3. And people are like, wait, what? Not 3? I'm like, right, yeah, it's not 3. No, it's not 3. Why would you say that it's 3? That's what I would ask next. Well, it's 3x. I'm like, that's great. But that's only if it's in the form y equals mx plus b. There's something wrong with this. X and y are on the same side, so this isn't in slope-intercept. So we actually have to move it, or solve this one for y. We learned in chapter 1. Now we know the slope of this line. Slope of this line is -3. Okay? Now, what's an equation for a line parallel to this one? Well, now it's super easy, right? As long as it has the same slope but different y-intercept, crushing it. Ooh, but this is really where it's at. Well, how about an equation for a line parallel to these? What goes to the point 6,8? Talk to your neighbor. Like, can we write an equation for a line parallel to these? also goes through this point. The slope has to be -7, but we only have a point. Oh, no problem. Point slope. And if I wanted to, I could write it into slope-intercept form. Boom. But either would be good. Cool. So if you know parallel lines, you just need to know this. Make sure you find the right slope and do it. So I'm going to set you off to do some practice. Writing equations that are lines that are parallel to this that go through specific points. Okay. All right, so with your neighbor, you would turn to talk. There's an example of one up here in case you lost any of those notes. Here are 6 examples. Make sure you identify the slope and do point slope. And even though it says write the equation in slope-intercept form, we recommend up here writing it in point slope first. So, slope of this line is 1. This point, the line here was what we're trying to find the equation for, is 5, 1. Boom, point slope. Okay, we want the equation for a line going through that point. We know it's parallel, so it has the same slope as this one. It goes to the point -8, 7. So, boom. We're going to turn these into slope-intercept later, but for now I'm just doing point slope. Alright, this line, what's the slope of this? What's the slope of this? I gotta solve it actually. It's not there. Gotta get y by itself. There's other ways, but okay. Now that I wrote this in y goes mx plus b, the slope is 4/3. So slope is 4/3. We have the point -33. So we can write the equation in point slope. Alright. Ooh, this one's nice. Ooh, sorry, couldn't see that. There you go. Next one, we have the point of the new line. We have the parallel line. So all I really need is its slope. It's 4. So I'm going to take that slope and use this point to write the equation for this new line. Same here. We're going to write an equation that goes through this point, parallel to this. Alright, parallel lines have the same slope. For a new line, it's the same, 1/3. This time we have to write an equation that goes through this point. Point slope, rocking and rolling, super easy. Okay, again, this is in y goes mx plus b, so it's fair to say that this is our slope, coefficient of x. Alright, our slope is -2, and our new line goes through this point with the same slope. Boom. Okay, here we know our slope. The new line has the same slope as this with this point. I'm going to go right into writing the equation. 3 times x minus -2 is y minus 4. Oof, not in y equals mx plus b. So, first I'm going to take away 3x from both sides. Boom, now I know the slope is -3. So take our -3 slope, and then we take our point, and we do it in point slope. Last one, we still have to, it's not in y equals clearly, so we have to get it there. This one's trickier, but our slope is -1/2. And now we can write the equation. Oop. we go. Now I didn't finish it fully. Each of them you should turn into Slope-Intercept as well, but I'm going to skip that step for now, as I don't have much space, but you should definitely have done this in your notebook. You know, leave yourself plenty of space. Okay, bring questions into class, and I will see everybody next class.